For those of you watching at home, how do I find inverse function? Okay. And number 2, how do I verify inverse function?
Did someone claim that no topic?
Yes.
Sorry, John.
That was yours?
What?
The one that was sitting here.
Oh, who claimed them? That one might have been mine.
That one?
Inverse functions. Guys, you did inverses. You just didn't call them this. You called them reflections. You did them in geometry class. When I had, guys, when I had points or shapes in geometry, I remember if we had a triangle on a coordinate plane, we'd call it like triangle ABC, right? And they'd tell you to do different things to it, to move it, to translate it a certain amount of distance or something. Did you ever reflect it over a line?
Yes.
Yes. When you reflected it over the line, y equals x, do you remember what you did?
Yes.
What?
You would make, I think it's one of them negative, one of them stays the same.
Yeah, you're hot. You're warm. You're not there yet. Guys, look at the point A. What's my coordinates
Honestly,
for
I
that?
just kind of counted up points of boxes.
Close. 2, 0. Okay. B.
-2,
-2, 3, and then C.
3, 5.
3, 5. Good. So if I want to find the coordinates A prime, B prime, and C prime, I want to flip them over this line, y equals x, okay? So just looking at it, A's, oh, I'm dying. Just looking at it,
Oh, you switch them. You switch them.
oh, hold on, Lucky's onto it. A's going to go here. Here's A prime. B prime is here, just flipping it over, right? And C prime's here. Lucky's got it. When I flip over, guys, when I flip over the line, what's up, Brent? You remember those notes? Were you not here? You actually weren't here on Friday. You got them? Because you left. Yeah, that's right. I might have an extra copy. I do. All right. We're on 6-4. What just got thrown? Because I noted it right. Lucky, what do I do in order to flip things over the line y equals x?
You switch your x and y.
I switch my x and y coordinates. So I flip A over the line y equals x. It's not 2, 0 anymore. It's 0, 2. I switch B over. It's not -2, 3. It's 3, -2. 1, 2, 3. 1, 2. And I switch C over, and it's now 5, 3. So you did not call this inverse. You call this like image or pre-image and then translated image, right? You may call it pre-image and reflection or translation. You call them a lot of different things. You didn't call them inverses because they weren't functions. It wasn't really an inverse. It was just a reflection. We're going to start talking about them as inverses. So to take the pre-image coordinates and find the image points after the reflection, we just switch x and y, right? That's all we had to do to reflect. An inverse function is the same thing. It's a function that's been reflected over the line, y equals x. So to find an inverse, and we'll call it relation, just to show it's an equal sign, but ultimately we're just talking about functions. Right, Riley? Right? Okay. All right. So to find an inverse, you're going to do 3 steps. First, just like I did with my coordinates, I'm going to switch my x and my y. Sometimes it won't be a y. Sometimes it will be f of x, right? G of x or h of x. For algebra's sake, change it to y, and then we'll change it back when we get to the a. We'll go through that. So I'm going to switch x and y. Then, and this is where it becomes everything you've done before, I'm going to solve, and you may have already solved, but I'm going to solve again for y. So I want it to be y equals So switch x and y, do my algebra, solve for y. And then to show that it's an inverse function, even if you were started with y, even if you didn't start with f of x, change your y. This is the symbol for an inverse function. I'm going to change y to, it looks like f to the negative first of x. Right? That's the symbol for inverse. It's not your function up to the negative first. Right? That's just the symbol. This f negative 1 means inverse function. So no matter what, at the end, change your y, change your h of x, whatever, change it to f inverse of x. Any other question?
Okay.
Yeah.
I was curious if switching before solving has an effect on your output.
Yes.
Yes?
It does. I don't think I give you any problems where you aren't already as y equals. That's just kind of how we've been working, right? A function is, like, we want an input and an output, right? That's one way of talking about x and y, domain and range, rise and run, input and output. There's a lot of different names for it. I want to put in a number, okay, into a function and get out one single number, y. I don't want to have, like, math happening to it. I just want to get an equals output.
Yeah.
So yeah, you need just a y equals, then switch. Okay, but I don't think that's a problem.
Okay, so it's like solve for y, then switch, and solve for y.
Yes, yeah, but like I said, you'll probably already have that y, so you'll just switch.
Okay.
But if you're not, yeah.
Okay.
Good. Yes. Like how far? So down here at the bottom, guys, find the inverse of the given relation. The relation, they're just saying that y equals, in other words, saying an equation, right? So y equals 3x minus 5. So according to my directions, what's the first thing I need to do? Switch x and y. And you're literally, I'm scrolling back down and good Christian. Okay, like to here. Okay, awesome. I'm literally just going to switch them. So instead of y equals 3x minus 5, x equals 3y minus 5. No problem. Step 2, solve for y. Right, we'll add 5 to both sides. That's plus 5 equals 3y.
Divided by 3.
And then divide by 3. So, and I'm not going to write y equals. Watch, I'm going to change this to inverse f of x equals. And I can write this as x plus 5 over 3. I can also rewrite that. This will come in handy. We're either going to...
Well, those are whale over there. Sorry. Sound like Dory. I hate those whales.
Guys, we'll usually either be graphing or we'll be plugging these in and solving with them. This isn't the best form for graphing. I can change this to slope intercept. I can split these terms up as 1/3 x plus 5 over 3, right? And now I've got slope intercept form. So for graphing, that's better. So if I'm asking you to graph, you can choose either method. For these purposes, find the inverse, and that's all I'm asking you to do. I'm not asking you to graph or verify. We'll get to that later. That's either one of these is an acceptable answer, right? So I'm good, but make sure you give me that inverse function sign right there for the cool curve. Questions? All right, keep going. Y equals x squared plus 2. First step. Luggy, switch x and y. I wasn't really going for calling on any, but apparently I need to. So solve, subtract 2 from each side. X minus 2 equals y squared.
So you take the square root of both.
Take the square root of both sides. F inverse of x equals the square root of x minus 2. Oh, you do? Is that okay? Yeah, if you left that off, I'd actually be okay with that if you left that off, because when you went to solve, if I asked you to solve anything, right?
Then you would need it.
you'd be giving me, you know, if it was 4 minus 2, so it's the plus or minus for, you give me something like that. But, can't work, right? Good. Do this next one on your own. What's weird about this exponent?
0.75.
What, I don't know if I told you about this. If I ever give you decimal exponents,
They're just fractions.
yeah, I'm only going to give you ones you can change very easily in the fractions. So what do you change? Yeah, change 0.75 to 3/4. All right, on your own, go. At this point, I want everybody to watch. When you've got something raised to a fractional, you know, a rational exponent like this, the way you get rid of it, a lot of us had said, we'll just multiply by the reciprocal. I think you know what you mean, and that you're actually raising it to a power, but saying it correctly matters. I need to raise each side to the reciprocal exponent. Okay, so I'm not multiplying by 4/3. I think some people might have done that between the two blocks on a quiz. They actually multiplied by 4/3, and then they just distributed a 4/3 here. So it's 4/3 x plus 8/3. No, we're raising each side to the 4/3 power. Because that makes these go away, leaving me with x plus 2 to the 4/3 power equals y minus 3.
So negatives do not matter. I didn't think they did. I was just wondering.
What negatives don't matter?
Okay. Yeah, I didn't think so.
Oh, well, then I have to add 3 to both sides, right? Leaving me with my inverse of x equals x plus 2 up to the 4/3 plus 3.
That's the answer.
Yes. I'd be okay if you change that to a radical. If you said the 3rd root of x plus 2 to the 4th plus 3, that's okay. I didn't specify to do as a radical or anything.
Yeah, wait.
You just want to find my inverse.
Wait, okay, so you multiply by.
So wait, when you're done here.
All right, guys. If I first step, switch x and y. So x equals the cubic root of 2y plus 3.
Guys, I'm gonna be like, I go to here.
Go ahead, Ruth. No, you're fine. Either way. Both sides, right? Guys, both sides get cubed. If I cube a cube root, the cube root goes away. And don't forget, I want to solve for y. So minus 3.
I have 4.
So
Right. No,
guys, either one of those. The first answer is
I got it right.
yeah, you just put the math out as it is. Folks, the second answer is slope intercept, which will be useful momentarily. Good. So that's how you find, guys, that's how you find inverses. And if you do that math correctly, Lauren, I promise that that will be an inverse, always. But how do I, we'll work the other direction sometimes. I'm just going to go, for those of us not paying attention, you can find me later. Problems in your book will work the other way. I'll give you 2 functions. I'll tell you, hey, one of these is the inverse. Verify. Prove to me that this is the inverse. So it's a proof, but you don't, nothing like an actual proof where you're going to write all these theorems and stuff, right? The way I verify that 2 functions are inverses of each other, you've been doing this actually. It's called compositions of functions. like I said, you've been doing this, but I'll get into it more. If I use compositions of functions, right, because when they reflect over y equals x, when I use compositions, both when I use compositions of functions, both of my compositions, and I'll show you why there's two of them, both of them will reduce down to x. So I'll just algebra, and keep reducing down to x. Riley, what will they reduce down to? Good. So verify that f of x equals 4x plus 2 and inverse f of x 1/4 x minus 1/2 are inverse functions. This is very much like questions from your book. How will you verify? So a composition, guys, is when I have two functions, and this is where you've seen this before. One of my compositions is f of inverse of x, and my other composition is inverse of f of x. That look like something you've done before? So I'm just going to take the x in each of those functions, my regular one and my inverse, and swap in the other function for x. That is just distribute and simplify, right? So both of these have to reduce down to x. We got to do them both every time. If one reduces to x and the other doesn't, not inverses. And that will happen more often than you think, actually. It's kind of like explaining the solutions. When you get two, how many of you try the first one and go, yeah, but the second one?
Yeah.
Yeah. No. More often than not, it doesn't,
I
right?
did that on the quest.
Yeah.
Except
I think. Yeah, I think on one of them it did.
yeah, I caught myself on
Maybe.
it. And on the
Tomorrow, I wanted to wait to create a name. That's why now you have, tomorrow you'll have them. We'll talk about it. So, f, we'll do the first one, and then I'll have to erase it and make room, right? So f of x, 4x plus 2, right? That was awful. 4, and I'm replacing x with what? 1/4 x minus 1/2 plus 2. This should reduce down to x. So let's distribute. 4 times 1/4 x equals 1x. And 4 times negative 1/2, negative 2, plus 2. What happens to these guys? X. It's a negative 2 and a positive 2, right? 4 times negative 1/2. What's the negative 1/2 and 4? Right. Well, 4 times negative 1/2 is negative 2. And then that positive 2 is just negative, right? From the original equation. Sure? Okay, here, I'll erase this. No. Crossing out is probably bad. Right. Ultimately, like those, that's what my, you need those like that. Does that make sense now? So 1x, 4 times 1/4 is 1. 4 times negative 1/2 I distributed. Right? Cool? Yeah, well, something is it. So that first composition reduced to x, right? So that's good. The other one has to also reduce to x. So guys, I'm halfway done. So I know that my first one reduces to x. So let's get the second one here. All right. So I need inverse of f of x, right? So my inverse function is 1/4, and I'm replacing my x with the original equation, which is 4x plus 2, right? And then minus 1/2. So I distribute what's 1/4 times 4x? 1x. What's 1/4 of 2? 1/2, right? So plus 1/2. Here's my negative 1/2. Leave me with just x. So these guys cancel, right?
And that is a inverse.
Yes. Why, Lucky?
Because they both reduce to x.
Both of my compositions reduce down to x, so this is an inverse function.
How much does your insurance really go down after 2.5?
Are you serious? One, a ton. Two, why?
Wait,
What did you say?
a lot? Really? Why?
That is my inverse function, right? So I did f of my inverse function of f of x, just like you did on your homework, where you would give g of h and f of h, square of x, right? Yeah. That's how we just did these. Okay? Alright.
Now I need to pinpoint.
Last bit, you guys. Alright, so that's compositions. Hey, we're not doing compositions for these notes. So, Lucky, Ashton, Holden, don't get confused here. Don't get confused here. Example 3, find the inverse, graph the inverse, and decide if the inverse is a function. So, I'm not using compositions. If it had then asked me, if it had given me 2 and it said, hey, find out if these are inverses, it would be compositions. I'm going back to the beginning here. I'm given a function. Keep in mind what you did back here. Find the inverse of the given relation or the function. That's all I'm doing here. Find the inverse, graph it, okay, and decide if the inverse is a function. What is the name of the test I do to find if something is a function? You guys remember?
Composition of functions.
No, that's what I did to find out if something's an inverse.
Oh, something's a
I'm gonna find the inverse, and I know it's an inverse. I want to know if that inverse is a function. You guys remember a test with a line?
The straight line test.
Well, there's a straight line.
Vertical line test.
Vertical line test.
Straight line.
Christian. And there's a straight line. Christian, how do I know if something passes the vertical line test?
I don't know.
No.
It's the above.
No.
It's to the left there too.
Guys, if I draw, listen up. If I draw a vertical line, straight up and down, at any point, if it touches that line, the function, more than once, it is not a function. So a vertical line can only go through one point. So let's show it. The inverse of 2x plus 1. So switch x and y. X equals 2y plus 1. X minus 1 equals 2y. So inverse of x equals
X over 2 minus 1/2.
good. So I'll do 1/2 x. That's good. Minus 1/2. So roughly graph this. I know my negative 1/2 for a y-intercept. Rise over run. Up 1 over 2. Up 1 over 2. Over 2. Down 1 back 2. Down 1 back 2.
I think it passes.
That was terrible. But it's pretty close, right? 0, negative 1/2. That's my y-intercept, right? And then I'm just up 1 over 2, up 1 over 2. So move. Good, so vertical line test. Guys, if I draw a vertical line anywhere on here, question, am I going to hit more than one point?
No.
No. So is this a function?
Yes.
Yeah.
Yes. Both this inverse, and you knew that, it was linear. Anything linear is going to be a function, right?
Yeah.
No problem. Second one, x squared minus 1. Well, let's find the inverse. So x equals y squared minus 1. X plus 1 equals y squared. So my inverse function equals
The square root of x plus the square root of 1?
just
Plus or
1.
minus?
Just plus 1. That whole thing, right? Because I'm square rooting this whole value.
Oh, yeah, you're right.
You can't split that up because it's addition, not multiplication, right?
So then all of the things that you're just doing the opposite of what it's doing. So like x plus 1 equals y squared, the opposite of y squared, or square root of a square root.
Yeah. If you want to think, guys, Lauren's making a point. You can think about it. You can logic out a lot of these. You can say, what is happening to x? It's being multiplied by 2 and added 1. So what will happen to the inverse? Well, 1 will be taken away, right, and then it'll be divided by 2. So you can think about that either way. What's happening to x? It's being squared and 1's taken away. So add 1 and then take the square root. Either way, I prefer the x and y switch methods. Okay? All right, guys, have we gone over how to graph radicals? No. This is what's weird about this chapter. Why is it having me do this? We know how to graph a parabola, though, right? Let's graph the original function, x squared minus 1. Is that just a standard parabola? Where's my y-intercept at? Yeah, -1, right? So standard parabola, but my vertex is just down here a little. We'll go over how to graph these tomorrow, how to graph radicals. Luckily, you don't have to know how to do that in order to figure out if this is a function. If I use the vertical line test to tell if something is a function, do you think there is a test I can perform on a regular function, something I know is a function, because I know that parabola is, right? It passes the vertical line test. Is there a test I can do to that to see if it will pass the vertical line test for its inverse?
Horizontal.
A horizontal line test. No, it actually is, guys. The horizontal line test doesn't tell me if this is a function. The vertical line tells me if this is a function. The horizontal line test, and this is actually kind of cool, and have we taken trig yet?
No.
When you take trig, this is... Well, I'm just asking.
No.
People are like angry about it. I'm just I just don't know how your order of classes work. When you get to trig, this is actually very important. If something fails a horizontal line test, then its inverse is not a function. So, will this pass a horizontal line test? No. No. It goes through more than one point, right, Judy? Which means it fails. Think about it. If I draw my imaginary y equals x, and again, we haven't gone over how to graph this, but if you think about this reflecting, oh, it's terrible. There's the reflection of that graph, right? Across the line, y equals x. That's how we determine inverses, right? Does that pass a vertical line test? No. So this was check, yes, a function. This guy, not a function. All right, D. Or no, C. We want C. Sorry. Here's C.
Wait. Time out. On that inverse one.
All right, for C, guys, remember back here, what did I do to flip those coordinates across to an inverse? I switched x and y. On your homework, you'll be given functions, you'll be given pictures, you'll be given data, just data, right? X's and y's. What do you think I do to each of these points to find the inverse? Switch x and y, right? So instead of, if I wanted points A, B, C, D, and E, these will be A prime, B prime, C prime, D prime, B prime. And then just connect the dots and see if it's a function, right? So, let's do it. So here's my C. So when I plug in, if I want A prime, it's not -3, 2. It's 2, -3, right? So here's A. B prime is 3, -1. C prime is not 0, 4. It's 4, 0. Let's say that's C prime. D isn't 2, -2. It's -2, 2. What in the world, guys? What's that going over there? Right? No, it's right though. Thanks. I know it's weird. And then E isn't 5, -1. It's -1, 5. So connect the dots. Guys,
Its inverse is a function.
it is?
Its inverse is.
That is the inverse.
Oh, that's the inverse?
Right.
Oh, well, then no, it's not a function.
Right. Where? Which one? This one? It goes A, B, it goes A, B, C.
What the heck? What's a B?
Yes.
B, and then that's the B.
Guys, I don't even think the original of that was a function. So if your original is not a function, your inverse probably is, and you need to check.
I
But
think
that,
the
that's
original-
in no way a function, right?
No, it's backwards.
It's a weird Z-shaped thing. That fails the vertical line test several times. Good. This last one. Without yelling it out, somebody raise your hand. Tell me if that inverse will be a function or not. Gigi. No. Why do you know that won't be a function? What will cross 2 points? Not the vertical, the horizontal line test. Guys, this passes my vertical line test just about everywhere. Not just about, absolutely everywhere. But it fails the horizontal line test literally everywhere. Meaning that its inverse, Ashton, will what?
The vertex?
Will what? Not be a function. Example 4. Let f of x equal 3x minus 1. Find the inverse of f of negative 2. So what's the first step I need to do for this problem?
Plug in -2 for the function.
Good. You can do it, actually you can do it one of two ways. First thing you can do is evaluate f of negative 2. Then what will you have to do?
Put that in for the inverse and solve for.
Yeah, but you're going to have to
switch.
find the inverse, aren't you?
Yeah.
Or you can find the inverse and plug in negative 2. Either way, find the inverse, evaluate f of negative 2, and finish the problem. On your own. Go. Everybody. Last problem. Hey, everybody.
Let's bring it in.
Way too many people missed this.
Yeah, we're not going to do it.
This is just like the homework problems you did, except it adds an inverse. So, this is asking me to, one, find the inverse function, which I will do first, okay? And then I want to substitute x in for that inverse function for f of negative 2. So the first thing I'm going to do, I look at this and I go, you know what? I'm going to have to find the inverse. Lauren, what's the first step for finding the inverse?
You have to flip Y. You have to flip a.
Flip y and x. Now, I don't have a y, I have an f and x. F of x.
And then Y.
Right, so I'm going to switch that. So, x equals
3Y.
3y minus 1. Good. Means x plus 1 equals 3y. Which means that y equals, and actually I'm going to change it to my inverse function. X plus 1 over 3. And I can leave it like that. Guys, I can leave it like that. You can move it, change it to slope intercept, that's fine. I'm going to leave it like that because I don't need the graph, right? I just need to calculate. So I'm going to leave it like that. Good. I'm going to use that in a little bit. So there's that. So eventually I'm going to plug in something for x there. First, let's evaluate f for negative 2. So here's my function. Oops, minus 1. Right, so all I did was take my original function, plug in negative 2 for x, which equals, and a lot of people got this. A lot of people got like half of it. They either got this right, or they got this right. Right, so negative 7. I put little squigglies when I know it's not my final answer. Boxes of the final answer. So, guys, f of negative 2, I can scratch this out. I've evaluated that, and it's negative 7. So my inverse function I need to evaluate for negative 7. Final step. Equals negative 7 plus 1 over 3, which is what? Negative 6 over 3? Negative 3. Boxes for final answers.